And I'm Ronald.
We are here to introduce about the Sonar project to develop a basic radar Arduino and ultrasonic technology that is capable of detecting objects in semicircular field and visualizing them in real time.
You need to understand that the several parties work together in order to achieve the powerful ultrasonic sensor.
Applications which are used for basic radar Arduino are automated parking assistance system, robot navigation, industrial automation, surveillance and security system.
In addition, airplanes, submarines, and humanoid robots.
Note that this project demonstrates how simple, low cost of components integrated by the minimal radar technology for education or for typing purpose.
Today we show you how the ultrasonic sensor is rotated by the servo motor with the help of Arduino Uno, and will display what you see on a laptop through the processing software.
The Arduino Uno acts as our project's brain, coordinating the inputs of the ultrasonic sensor and managing the angular movement via the servo motor. The function used: digital write function, pulse-in function, servo.write function, and serial.print function. The loop sweeps server and takes readings.
Arduino sends a 10-volt spin-high signal to the trigger pin. This triggers the sensor to send out an ultrasonic pulse at 40 kHz. If the pulse hits an object, it reflects back. The echo pin goes high for the time to look at the pulse to travel to the object and back.
The data output. This logic ensures precise synchronization between the server angle and the corresponding sensor and sends the data to the processor for visualization.
Arduino IDE is used to write and upload code on the Arduino board. Language is based on plain C and C++ with some simplifications. Sends angle and distance through serial.print to be read by processing.
The role of the Arduino Uno acts as the controller, reads the sensor data, sends the data to the computer via the USB, and controls the servo motor.
To understand the meaning of the ultrasonic sensor,
the ultrasonic sensor is a device used to send and receive the ultrasonic pulses through which they are used to detect the object distance. In the ultrasonic concept, it uses sound waves to 40 kHz, which is not audible to humans. The ultrasonic sensor serves as both a transmitter and a receiver. We use time-based measurement to measure the object range. The servo extends the sensor's field of view by rotating it smoothly. The ultrasonic sensor has several pins. Example, the trigger pin, which is the input pin and linked to Arduino D12. The second is the echo pin, which is linked to Arduino D11. And the third is the VCC, which removes a maximum of 5 volts, and the ground connection, which is the GND.
Moreover, to understand the concept of ultrasonic sensor, the ultrasonic sensor uses sound waves to measure the distance between itself and an object.
If you want to know what's the servo motor,
a servo motor is a rotational actuator which is used for precise control for angular position.
In simple words,
a servo motor is a position-controlled motor. I'm going to explain the internal part of the servo motor. Inside the SG90, you will find the DC motor that provides the action movement, the gearbox that slows down the motor and it increases torque, the potentiometer or the variable resistor that tracks the shaft position, and the control circuit that compares the desired angle with the current angle, and it adjusts the motor until they match.
Servo signal Arduino D11 power management. It is powered by via USB or external 9-voltage battery. Servo should ideally have separated power in order to reduce jitters. Proper grounding and secure jumper connection are vital in ensuring signal integrity and minimizing jitters.
Why did we use the servo motor? Unlike a normal DC motor that can spin continuously, a servo motor can rotate at a specified angle, which is ideal for rotating the ultrasonic sensor from 0 to 180 degrees, returning it back to its normal position and holding its position without constant power.
Challenges. The first challenge was servo rotation delay. This can be solved by capacitors moving and external power. The second challenge was distance reading fluctuations. This can be solved by multiple reading.
How this radar system works depends on the Arduino Uno.
To answer the question how,
the Arduino Uno receives instructions.
So where do these instructions come from?
We programmed it by passing the code to the Arduino Uno component from the IDE Uno by passing the code to the laptop using the USB port.
Purpose of the code. This code creates a basic radar of the sonar system by using ultrasonic sensor HCSR04 to measure distance. Servo motor rotates the sensor from 15 degrees to 165 degrees and back. The serial communication to send angle and distance data to the computer, usually used in processing to visualize data.
Moreover, the code explanation, which includes the servo.h library input. This imports the servo library to control the servo motor. Second, the ultrasonic pin setup, whereby there's the trigger pin which it sends the ultrasonic pulse. The second, the echo pin which receives the reflected pulse to measure the time it took to return.
Third, variables for measurement: duration, time in microseconds in order for the echo to return. Second, distance, distance calculated from time. Third, my servo creates a servo motor object so you can control.
In addition to that, the setup functions. The setup pin modes start serial communication at 9600 bps to send angle or distance to the PC. Attaches the servo motor to the digital pin 12.
First loop, 15 degrees to 165 degrees. Move servo from 15 degrees to 165 degrees in 1 degree step at each position. Wait for 30 microseconds. Measure distance. Send angle distance data in format like 15 degrees 150 angle distance.
The second loop from 165 degrees back to 15 degrees. It has the same logic, but it's now scanning backwards.
To answer the question, that's the function of a processing software. The processing software enables us to display information of what the sensor sees.
Reads your data in real time. Maps polar coordinates, angle plus distance to quotation XY. Draws radar lines and points to simulate real radar. Processing helps in translating data into a dynamic output, offering an immediate feedback of object presence and location.
Moreover, accurate within 1 to 2 cm for objects greater than 50 cm. Better detection for higher surfaces than soft ones. Known objects placed at fixed angles and distance. Check consistency of distance readings and radar display. Multiple test rounds help validate accuracy. Adding delays and fill time help to reduce erratic behavior due to environmental noise. Serial mic ports, serial communication object, strings, angles, distance and data. Stores values from received Arduino. Eye angle and eye distance. Percentages from above. Fixed distance. Distance in pixels for radar display. P font or font. Font declared but no used.
In addition to that, serial read string, translating function, rotate function, line function, and ellipse function. The processing code is for visualizing data in an Arduino-based radar system. It helps to read serial data sent by an ultrasonic sensor mounted by a servo motor. It displays detected objects, angle, and distance of a radar-like user interfering.
We needed the power to power the Arduino to be able to rotate the ultrasonic sensor across the detected zone, and processing system using the processing software 5 also sent. The USB is used to power up the Arduino. As you can see, the USB from the laptop is connected to power up the Arduino.
Instead of only teaching theory, we decided to let pupils create working solutions. This approach not only solves small-scale problems, but also gives pupils a sense of ownership and pride.